This is my video solution for question 4 of a set of 5 questions recently released from BFW. These 5 questions aren't official College Board questions, but they were written to be of a similar style and difficulty. You can download a PDF of all of the questions via the link that I provided in the description below. And I do encourage you to try these questions on your own before watching my solution videos. Now, in one of my previous videos, specifically the one for question 2 from this set, I included a number of tips on how to write paragraph-style questions in general for the AP Physics exams. So if you haven't seen those videos yet, I'd encourage you to watch them before watching this video, as in this video, I'll primarily be focusing on the specific question that we're given here and not so much on general tips. So with that said, let's get right into this question. So this question is largely about projectile motion and energy. I've already written up my response to it ahead of time, so I'm just going to show you the question, show you my answer, and then we're going to score my answer. In fact, in a previous video, I tried to write up a solution utilizing the scoring guide. This time around, I went backwards. I've actually written up my solution ahead of time without looking at exactly where the points are, so we're going to score my question, and I will hope to see if I get all the points. So what we have here is a device used to launch an object from the edge of a platform 5 meters above the ground. So projectile motion, although in this case here, we have it launching from a rather large height of 5 meters. So let's just imagine that there's the floor down below, and 5 meters above, there's some kind of a launcher. So to determine the speed with which the device launches the objects, you set up a motion detector to measure the final speed with which the object strikes the ground. Now you realize that you do not know, in fact, let's just stress that you do not know if the device is set to launch the objects vertically upwards or vertically downwards. So I'm imagining that this is at least initially out of our sight. Somebody else has launched the projectile. All that we're doing is observing the impact at the ground. Now part A says that one student argues that in order to find the launch direction, you would need to observe the initial direction of motion directly, basically. So you'd have to look, according to this student, if you wanted to determine which way it was launched, vertically upwards or vertically downwards. Our task is to write a clear, coherent, paragraph-length response, and of course that is standard language for prompting us to start writing a paragraph-length response, to describe why the student may believe this, and, if you agree or not, if there is another option. We're asked to define our system and support our argument with a detailed description of motion of a launched object for both an upward and downward launch. So that's part A. I'm also going to just kind of clarify. Part B is rather short by comparison, so let's look at this all together, and then we'll look at my answer altogether. So part B changes the situation to a completely separate trial. Again, in part A, it was definitely a vertical launch. We were just trying to compare a vertically upward launch versus a vertically downward launch. So part B says the launcher was set to launch the object horizontally from the same initial position. Now, I did notice that the question didn't specify the launch speed in this horizontal launch, so I think that I'm going to have to assume that it was intended to be there, or intended that we would assume it, that the speed is going to be the same in this horizontal launch. Otherwise, it would be too wide open, I think. So I'm going to assume that it was just information that either was missing or that I was expected to assume. So I am going to assume the initial launch speed is the same. The question that I'm then asked is, how do the final velocity and speed of the object compare to that of the object launched vertically downwards? And of course, we're asked to justify our answer. So like I said, I've already written up my answer. I think it will hopefully be a complete answer that'll get me all of the points. Let's have a look at it, and then we'll score it using the official scoring guide provided by the author. Okay, part A. Again, I broke this up into little parts. The first part is this. And I'll remind you that the question that I'm really addressing here is, why might the student have made that claim? The claim specifically that you would have to observe it to determine if it was launched up or down, in the case of a certain vertical launch. So my response to that is, I don't know, the student may believe that the initial direction of motion can be determined only if it is observed, because she thinks that it cannot be determined based only on the information that is otherwise available. i.e., we know that the height it was launched from was 5 meters, and of course we have measured the final speed of the projectile. So from that information alone, maybe the student says, you can't possibly tell from that alone if it's up or down. Therefore, this student claims you would have to observe that launch to see if it was up or down. We were also asked to see if we agree with that, and of course to give a full explanation as to why or why not, and bringing all of this physics into play, of course. So my response to that is, I do agree that the launch direction cannot be determined from the above information alone. This can be understood from an energy perspective. And before I go any further, I'll just comment here. I was initially considering either an energy-based approach or a kinematics-based approach, and just thinking it through a little bit, I think that either method could be used fully and correctly. I chose an energy perspective because there was mention of, defining the system, so that's usually a bigger deal with energy. And I also thought I could probably more clearly communicate my thinking using energy than I could with kinematics. I would think, though, that either way would be okay. So, considering the system, remember that I was told to define my system, so I'm going to consider the system composed of the object and Earth. Including Earth in my system does grant me access to the concept of gravitational potential energy, which I thought would be really useful here. So with that system defined, my system would start with the same kinetic energy, regardless of the launch direction, assuming that the speed of the launch is the same either way. And regardless of the path taken by the projectile in moving to the ground, the system transforms the same amount of gravitational potential energy into kinetic energy, as in either case the object begins at the same height, 5 meters, and ends at the same height, 0. And of course, I didn't say it, but that's measuring from the ground, which is a very, very typical, usually you don't need to explain that. The object would therefore arrive at the ground with the same kinetic energy and therefore have the same speed, in either case. Now, because the final speeds would be the same regardless of the launch direction, the landing speed cannot be used to determine the direction of the launch. So I think that is pretty clear. So I do agree that the information we have is not enough. But remember that the student also claimed that the only way to determine it would be to observe it. So look at which way it was launched. Now, obviously, that'd be a really easy way to do it. I mean, if you were unsure if it launched up or down, by all means, look at it. But that wasn't our question. Our question wasn't, is this a good way to do it? It was, is this the only way to do it? Is there any alternative? There occurred to me one really, really obvious difference between launching up and launching down. So my continuation of part A is, I do not, however, agree that observing the initial direction of motion is needed in order to determine the launch direction. There are other options. And of course, that was directly asked of me, are there any other ways of doing this? For example, and this is just the first thing that came to me, if you can think of anything additional, I'm sure it would be fine, but this is a very, very clear difference. For example, if the time taken for the object to arrive at the ground from when it was launched could be measured, so if we could know how much time it took to get from the launch position to the ground position, then the initial velocity, including its direction, could be determined using kinematics. So energy can't distinguish between those directions, but kinematics certainly could with a little bit more information than we originally had available. This is because it would take a longer time to reach the ground if it was launched upwards than if it was launched downwards. So I could have elaborated using some equations to support my thinking, but typically you don't need equations in a paragraph length response. Let's roll right into part B. Part B was comparing that horizontal launch to the vertical launch, specifically the vertical downward launch, I believe. So, part B, here's my response to it. As described in part A above, the change in gravitational potential energy, and therefore the change in kinetic energy at any speed, will be the same regardless of the launch direction. So up or down or other. It really doesn't matter what direction it's launched in. The final velocity, and don't forget that velocity is a vector, it includes direction. So the final velocity, however, will not be the same with a horizontal launch, as the direction of the velocity will be different. Specifically in the case of a vertical launch, in either direction, up or down, although they did specify down. The end velocity, when you get to the ground, will be directed downwards, i.e. with no horizontal component. But in the case of a horizontal launch, the velocity will have a non-zero horizontal component. since the horizontal velocity will be constant throughout the motion. So that is my answer to the question. And I think I've addressed every point. I'm always big on this, and if you've watched a number of my videos by now, you'll hopefully immediately recognize this repetition and maybe even anticipating what I'm going to say. Make sure you've answered the question. So let's just do a quick recap. Did I actually answer the question? Okay, so the question, if I just kind of cut to it, part A, one student argues that you'd have to observe it. Why the student may believe this, okay? So definitely, if you recall, I've addressed that. If you agree or not, I've addressed that. Define your system, I've addressed that. Okay, so compare the motion for both the upward and downward launch. Make that comparison. I've done all that. Part B, in another trial, it was launched horizontally. The question being asked is, how do the final velocity and speed of the object compare to that of the vertical launch? I've definitely addressed that, and I've definitely justified my answer. So as a student, if this was you writing your answer to this question, once you've completed your answer, definitely, hopefully you have a little bit of extra time after finishing it, go back and verify that you have not missed anything. Especially if it was a question like this where really, although it's broken into part A, part B, there were many, many little things that we were tasked to do. Do make sure that you don't miss any of them. Like I said, I don't know where the points are right now. I thought I would simulate a closer to what experience you're going to have, in that you're going to write you're going to write your answers not knowing where the points are. By the way, that's always been true of AP Physics exam questions. You might know that a question is worth a total of so many marks, depending on the question, but you really don't know even how much part A is worth, how much part B is worth. If there's multiple parts beyond that, because some AP questions I've seen as many as, 7 or 8 sub-question or sub-parts, right? Part A, part 1, part A, part 2, and so on. So there can be many parts, and you don't always know where those points are. So right now I have no idea, but let's go into it. I did paste them in, but I did my best to avoid even reading them. I just pasted them into this document, crossing my eyes practically to not see exactly what it said. Okay, so let's see how I did. We're going to mark my question, and I'm eager to see if I get all the points. If I miss anything, so be it. Hopefully, if I better get at least 6, or actually, I forget how many points this is worth, so hopefully I don't miss more than 1. If I miss only 1, I will say I'm happy with that. If I miss more than 1, I'll be a little bit disappointed. Okay, so let me just kind of clear this out so we can clearly see my scoring here. There we go. Get rid of all of that. That's just, I like to highlight it when I'm talking to you so you can kind of see where I'm looking since you're only seeing my screen. Where are the points? Okay, so part A was worth 7 points. Just scrolling down real quickly, part B was only worth 2 points. Okay, yeah, that does make sense because there's way more to say in part A. 7 points in part A. Let's see how I did. Okay, so 1 point, let's just kind of do it point by point here. 1 point, what did we have to do? For using Newton's second law, okay, now I definitely did not do that. I didn't think it was needed though. So using Newton's second law in one dimension, perpendicular to there, so horizontally, either explicitly or implicitly, to correctly describe motion in the vertical direction. Okay, good. Phew, I was actually starting to get a bit nervous there. Or, okay, this is the saving grace for me, because otherwise I was thinking, wow, I would be so embarrassed to start off missing the first point. Yeah, okay, so you could have used a kinematic-based approach, but if you did use a kinematic-based approach, you would have had to go one level deeper and explain why the motion is the way it is. You'd have to explain, for example, using Newton's laws, how you could figure out the acceleration, or at least a comparison to the two cases. So, phew, I have a note here. Or using gravitational potential energy of the Earth object system. Okay, so I did define my Earth object system. Okay, but they're covering all the bases here, because if a student had said, I will define my system to be the object only, that would have been okay, because had you done that, you could have described the effect of the force of gravity as an external force doing work. So I didn't do that, but it's nice to see that this first point has a range of options available to how a student could earn that point. So you could have used a force kinematic approach, or you could have used an energy approach to earn this point. By the way, doing both would not have granted you more than the 1 point. So don't be redundant. If you explain something fully and clearly the way I think I did, there's no need to say, oh, by the way, let me impress you with a totally different way of arriving at the exact same conclusion. At that point, you are wasting your time. So let me identify exactly where I did that. And of course, I think it's throughout my answer. So using gravitational potential energy of the Earth. Okay, so using it, definitely. That's pretty early on here. So my system was composed of the object and Earth, etc., etc. And then I absolutely used the concept of potential energy. I'm just kind of scanning to see where I put it. Oh yeah, the amount of gravitational potential. So as soon as I'm making use of this concept, whether it ends up being right or wrong, because that's going to be, I think, points down below, but just for using the concept of potential energy and my object Earth system, that would earn me that point. So point number 1, I'm awarding to myself. Whew, okay. Let's see if I get the... Oh, what happened there? Accident. Get back on there. Okay, so second point. Let's switch to green for contrast. Okay, so 1 point. For stating that an object... Okay, now just to be clear, stating means you really have to have said it. Okay, you can't just imply it or anything like that. So for stating that an object launched upwards has a velocity of 0 at its maximum height... Okay, so I didn't say that, but again, I think there's going to be the or, yep. If you took a kinematics approach, that would essentially be necessary as you're describing the upward movement and the downward movement. So, okay, I didn't do that first part, but let's look at my energy alternative. Or, correct energy argument for the same, okay, here we go, same kinetic energy at the launch height regardless of the launch direction. Got that. I know for a fact I said that. In fact, I said that very well, I think. So, where did I say it? Right here, I think. Regardless of the path taken by the projectile and moving to the ground, transforms the same into that and that. Okay, where did I say it started, though? I'm pretty sure I said that. Considering... Oh, phew, there it is. Okay, would have started with the same kinetic energy. Right, because if I want to say that it ended with the same kinetic energy, which is where I was really headed with this, I really had to say two things. I had to say that it started with the same kinetic energy, and ultimately I had to say that it acquired the same additional amount of kinetic energy. So as soon as I see started with that same kinetic energy, I'm golden on that point. So let me scroll back down and say, yes, indeed, I earned that second point. All right, let's see if I earn the third point here. To earn the third point, I could have used either kinematics, which I did not do, or gravitational potential energy, yep, that's my approach for sure, of the Earth object system to explain that the object has the same velocity when it reaches Earth's surface for either direction. Okay, so I definitely did that, although it's going to be probably a little hard to pinpoint for me because it's rather spread out over, I think, a couple of sentences, so I don't know if I'll pinpoint this one. How do I prove that it ended up at the same velocity using an energy-based approach? Well, I don't know, I guess it starts maybe somewhere around here, regardless of the path taken, up or down. Because the gravitational potential energy is, transforms the same gravitational into kinetic energy. In either case, the object begins with the same height, elaborating lots of probably more detail than I needed. The object, the object would therefore arrive at the ground with the same kinetic energy and therefore the same speed. Okay, so that's what we are ultimately after. And we needed to give a clear explanation using either kinematics or, in my case, energy, that would in fact be the case. So although I've kind of skimmed over it right now, I think it's all there and it's all clear. So I am going to award myself that point. And I think I missed that one, or it got deleted somehow. There it is. So I'm 3 for 3 right now. That means I'm pretty happy. Okay, moving on. We have a fourth point. What did we have to do for the fourth point? For identifying the time of flight as different for the two scenarios as another option. So yeah, the student had made the claim that the only way to do this would be to observe it directly, and we were to identify the difference. Now, I didn't actually think about it through all that much, to be perfectly honest with you. The time of flight was the first thing that occurred to me. I had maybe I didn't think about it all the way through. I'd assumed that there would probably be other ways depending on what latitude we have here. So this point is specifically calling out the time of flight being different. So I definitely have that. Just surprised that it's a little bit, or that it's so specific here. I would have assumed that there must be some other way of doing it. If I want to be really creative, I'd probably come up with something like, hey, I don't know, okay, this is being silly a bit. How about if we place something immediately above the launch position and listen to see if it impacts it or not? Okay, so we could listen for, did it crash into whatever we put right above it? I certainly wouldn't use that as my answer, but I'm just pointing out that if you're really, really stretching, you could probably come up with other ways. Nonetheless, the time of flight being different is coming up here. Yeah, because I do not agree. And I called out, for example, if the time taken right around here could be measured, then it could be determined because it would take here it is, right here, the longer time to reach the ground if it was launched upwards than if it was launched downwards. So there's definitely a different time of flight in my answer. So I award myself that point. Hey, don't you wish you could award yourself the points on the AP exam? That'd be kind of nice for you guys. All right, for using the next point here, I'm going to switch to highlighter. For using a correct physics argument to relate their argument, correct physics argument to relate their argument on whether or not there is another option, whether or not their other option or lack of an option was correct. Okay, my interpretation of this would be focused right here, using correct physics, of course, to relate their argument on whether. So we had to say, oh, okay, I think I get it now. I think I get it. We had to say, was there another option? Essentially, yes or no. So I think that this is giving us a little bit of latitude. That's kind of nice. If a student on this exam had said, no, there's no other way of doing this, I agree with the student that you'd have to observe it directly. I think that you would not have earned, I guess, this point. You probably wouldn't have gotten that one. But they're still giving you some latitude of earning this point. Because I guess if you had said, no, you'd have to observe it directly and then somehow justify that using physics, even if you're missing a nuance, then I think there'd be some option of earning this point. Okay, but because I did say there is definitely another way of doing it, I think I earned that point kind of again throughout this whole paragraph pretty much. So I'm not going to even try to pinpoint it, but I absolutely used correct physics to defend my position of, no, I don't agree, there absolutely is another way, and let me explain the physics of that. So I think in this paragraph, kind of throughout, I would award myself that point. So I guess I'll use the highlighter to give a big check there. The next point, switching over to yet another color here, for identifying the correct system to support the argument used, so that would be the Earth object, in fact, that's what I'd use right there, so straight away, the Earth object system, if you're using gravitational potential energy, but of course, there's other ways you could have done it. You could have alternatively said an object consisting of a system consisting of the object only, which you should have said if you chose to use that other approach, including that Newton's Laws kinematics approach, which I didn't do. So nonetheless, I definitely did that. Let's pinpoint it where I did that. I think it was fairly early on where I defined my system. Cannot be determined from an energy perspective considering the system composed of the object and the Earth, the system would, etc. Okay, so I definitely defined my system and then used the correct physics based on that system. So I'm giving myself that point. And this last point for part A, at least, is that floater point. I'm not going to highlight, I'm not going to pinpoint it. This is a pretty typical point for just summing things up and saying, overall, holistically, was it logical, relevant, internally consistent? Did it have any things that aren't explicitly mentioned here because there's other requirements? Did it have any errors in it, etc.? So you could lose this point if you were rambling on about irrelevant things. You could lose this point if you have an incorrect statement inside of your answer anywhere. And I don't think I have any of those issues, so I am giving myself that point. All right, so far so good. I'm doing all right. 7 points out of 7 points on part A. Shifting over to part B. In fact, you know what? I think I'm going to recycle. I only have so many colors here. So because I didn't pinpoint it, I will save green for over here. So 1 point in part B now for having a change in gravitational potential energy of the Earth object system that is the same or time for which it is accelerating longer, or the component that is... Okay, so you have all kinds of options available to you as to how you might justify this, but I definitely did this first option. The change in the gravitational potential energy is the same. So I guess you still could have used a kinematic-based approach, but I did not do that. I absolutely said in fact, almost word for word, the change in gravitational potential energy, and therefore all of these other things will be the same. So I've, again, used probably far more detail than is needed, but just for clarity, the extra detail I gave is not irrelevant, and it is not incorrect, so that would certainly not jeopardize any points being lost for that, for example. It is okay to be clear. Sometimes you might be unsure as to how much you need to say, but you'll never get in trouble for saying things that are correct and relevant. Just to clarify that. Okay, so I get myself that point. One more point. Am I going to ace it or not? Let's find out. The final speeds will be the same. This is in that horizontal launch versus the vertical launch. So the final speeds will be the same, but the final velocity will be different as there is now a horizontal component. And I know I nailed that one for sure, because as soon as I saw the word velocity, I'm immediately thinking, aha, speed versus velocity. Velocity is a vector. It includes direction. So I definitely got that in here. Okay, so right here. So therefore where did I have it? The ending speed will be the same. So we kind of already touched upon that a moment ago. The velocity, however, will not, because of and I'm not going to elaborate from here, but there was definitely that non-horizontal component in the vertical case, but there was absolutely a horizontal component. Let's see here, where was it? The velocity would be directed, no horizontal component. Oh yeah, non-zero component versus no horizontal component. There it is. So I think I am going to award myself that final point. And I honestly was hoping I would, but I would not have been too surprised if there was some nuance in here that I missed. But I'm happy to say that I earned all the points here. So hopefully that was of some benefit to you. I think that's the end of this video.